Hello everyone. Good morning. I am Nikunj, your physics teacher from QNI, and I welcome you all to the QNI class. How are you all? Good morning, everyone. Am I audible? Please confirm. Am I audible? Anay,
Yes,
Arush.
sir.
Okay, very good. So let's start today's lecture. Okay. So before starting the lecture, first we will see what are the prerequisites. So first one is basic mathematics, like basic addition, subtraction, multiplication, and division. Okay. Then about distance. Okay, what is distance? What is displacement? Okay, now speed. Okay, so these are the some prerequisites. Now if we talk about the weightage, so from this chapter approximately 7 to 8 marks question asked every year. Okay, now if we talk about what we are going to study today, so we'll see the equation of motion. First is velocity time relation, then displacement time relation, and third the displacement velocity relation. And based on this we will solve some questions also. Clear? Okay, so let's start today's lecture. So in the last class, I've given you one question at the homework, which is the velocity time graph for uniformly accelerated motion, and we have to calculate the distance traveled from 10 seconds to 20 seconds. So have you solved this question? What is the answer? Tell me. Okay, so let's have a quick recap of the last class. So first one is the distance time graph. So please tell me what is distance time graph for uniform motion? It is a straight line or a curve? Distance time graph for uniform motion is a straight line or a curve? Tell me. Distance time graph for uniform motion. Straight line. Very good. Okay, very good. Now, motion for non-uniform motion, there is some curve. Okay, there is some curve. Very good, very good. Now, if we talk about the velocity time graph for uniformly accelerated motion, so it is a straight line and also given here. But if acceleration is not uniform, so curve may be of any shape. It is going upward, then upward, then downward, or it can go downward. Okay, it can take any shape for yes or no. Is it clear to everyone? Any doubt? Okay, very good. Now, what is the answer of this question? We have to calculate a distance traveled from 10 seconds to 20 seconds. Okay, if velocity and time is given, how we calculate the distance traveled? Is the distance traveled is the area under the graph? Yes or no? If velocity time graph is given and if we calculate the area for the given time interval, we get what? Distance, yes or no? If we calculate this area, we will get distance, yes or no? Very good. Now we can calculate this area. Now I'm dividing this area into two parts. First one is your rectangle and the second one is triangle. Okay, let's say this is A, B, C, D, and E. So area, total area is equals to area of triangle ADE plus area of rectangle ABCD. Okay. Now what is the area of triangle ADE? So it is half base into height. Yes or no? So half base is 20 minus 10 is 10 into height is this length DE. Now here at point A and D velocity is same, which is 16, and at point E the velocity is 32. Yes or no? So this difference is nothing but 32 minus 16, which is 16. Any doubt till here? The area of this triangle is half into 10 into 16. Yes sir, very good. Now plus area of this triangle, which is length into breadth. Okay, now this from length B to C is nothing but 20 minus 10, which is 10. into this length CD. Now this is 0 to 16, which is 16. Now this is equals to 2 into 8. Now 10 into 8 is 80 plus 10 into 16 is 160. So 160 plus 80 is 240 meter. So the distance traveled from 10 second to 20 second is nothing but 240 meter. Is this clear to everyone or any doubt? Yes, tell me who solved this question. Okay, Anna. Very good. Aditi, okay. Okay, Arush, very good. Okay, now I'll see next question. Now here we have given the velocity time graph for uniformly accelerated motion and we have to calculate the acceleration. So everyone tell me what is the acceleration here? What is acceleration here? Now what is acceleration by definition? Zero. Why, Arush? What is acceleration? Tell me. Change in rate of velocity. Okay. Now if Arush, if acceleration is zero, so is there any change in velocity? Arush, if acceleration is zero, is there any change? Change in rate of velocity in a particular time. Okay. Acceleration is change in velocity with respect to time. Okay. And change may be positive, may be negative, may be zero. Because velocity is a scalar quantity, sorry, vector quantity. Velocity is a vector quantity. It can be positive, negative, or zero. If acceleration is positive, that means it is supporting the motion. If it is negative, that means it is opposing the motion. That means if acceleration is negative, acceleration is acting opposite to the motion of the body. That means velocity of this body will decrease. Okay. And if it is zero, that means there is no change in the velocity. Velocity will remain constant. So Arush, if acceleration is zero, is there any change in velocity? Yes or no? If acceleration is zero, so is there any change in velocity? Arush? No. So here in the given graph, velocity is changing or not with respect to time? Okay, okay. 1.6 meter per second square. Okay, any other answer? Okay, no, very good. Arush 1.6. Okay. Now we want to know the change. Suppose I'm saying this is point A, this is B, this is C, this is D, this is E, this is F. Okay. Now we want change in velocity. Okay, no, very good. Now we know that acceleration is nothing but change in velocity with respect to time. That is some final value of the velocity minus initial velocity upon time. Now I'm saying from A to B. Now for A to B, the final value of the velocity is 16. The initial velocity is 8. Now at A time is 5 and at B time is 10 seconds. So time taken by the body from A to B is 5. Okay. From A to B is 5. Now what is final velocity? That is velocity at B is 16 minus velocity at A is 8 upon time. So 10 minus 5 is 5. Now 16 minus 8. Tell me 16 minus 8 is 8 upon 5. Now this is equals to 1.6 meter per second square. Very good. Now tell me this acceleration is constant or not for the entire motion. This acceleration is constant or variable?
Yes, sir.
It is constant. Okay, and how you can verify it? So you can calculate the acceleration from B to C, from B to D, from A to E, anywhere. And if acceleration is constant, so acceleration is constant, that's why there is a straight line. between velocity and time, because velocity is increasing uniformly. Yes or no? Okay, so I hope there is no doubt in the graphs. You can solve any question from the graph, yes or no? In fact, in today's practice session, we will practice from the graphs. Okay. Is this okay? Okay. For the better clarity, okay, for the better understanding. Now we are starting with equation of motion. Okay, so till now we know that what is speed, what is frame of reference, what is reference point, what is origin, what is distance, what is displacement, what are the scalar quantities, what are the vector quantities, what is physical quantity, what is speed, what is velocity, what is average speed, what is average velocity, what is acceleration, what is uniform acceleration, what is non-uniform acceleration, what is uniform motion, what is non-uniform motion. And we also know about graphs, that how distance time graph for uniform motion, for non-uniform motion, velocity time graph, okay, for uniform motion, for non-uniform motion. Yes or no? We all know these things. Yes or no? Yes or no? Okay. Now we'll see what are the equations of motion. So there are basically three equations which helps us to study the motion. Okay. Now they are called the kinematical equation of motion. Now what is the meaning of kinematical? Kinematics means there is no involvement of we don't know what is the cause of the motion. We don't know the cause. Okay, but we know the motion, but we don't know the cause of the motion. Okay, we know how velocity is changing, how acceleration is changing, what is the speed, what is the velocity at any particular time, what is the distance covered by the body, what is the displacement of the body. We know all these things. So these are the motion parameters, but we don't know the cause, and the cause we know is force. But right now in this chapter, we are not studying about the force, which is the cause of the motion. We are only studying about the motion. So the study of motion without knowing is called kinematics. The study of motion without knowing is called kinematics. Okay, so here there are the kinematical equations of motion. Okay, now it is not depending upon the mass, because here we are not knowing what is the cause of the motion, what are the cause of the motion. Okay, that's why this equation of motion is not depending upon the mass. Okay, now if I'm representing final velocity by v, initial velocity by u, okay, acceleration by a, time by t, and displacement by s. So we know that first equation of motion is v is equals to u plus at. First equation of motion is v is equals to u plus at. Now this equation gives the relation between the velocity and time, so it is called velocity time relation. That with respect to time, how velocity is changing is given by this equation, which is v is equals to u plus at. V and u are both are the velocities. Okay, okay. Now second equation of motion is s is equals to ut plus half at square. Now again this equation gives the relation between the displacement and time. Okay, s is the displacement and t is the time. So this is called displacement time relation. Now one more thing, what is displacement? So displacement is nothing but the final position minus initial position. Okay, so the second equation of motion can also be written as that final position of the body minus initial position of the body is equals to ut plus half at square. And if the body is starting from the origin, that means initial position of the body is 0. So we can say that xf is equals to ut plus half at square. Or if I'm saying that final position of the body is the displacement of the body, so s is equals to ut plus half at square. Okay, so remember please this point, that here displacement s is the displacement, and this displacement is nothing but final position minus initial position. Yes or no? What is displacement? Final position minus initial position. Yes or no? Any doubt till here? Anyone having any doubt? Yes or no? No doubt? Very good. Okay, now I'll see what is third equation of motion, which is v square is equals to u square plus 2as. Now here, this equation giving the relation between the displacement and the velocity. Displacement and the velocity. So this is called displacement time relation. This is called displacement velocity relation. Okay, so these are the three equations of motion. V is equals to u plus at, s is equals to ut plus half at square, and v square is equals to u square plus 2as, where s is the displacement and displacement is final position minus initial position. One more thing, these three equations of motions are applicable only when acceleration is constant. Only when acceleration is constant. If acceleration is changing with respect to time, then this three equation of motion is not applicable. Okay, if in any question acceleration is changing with respect to time, so this equations of motion is not applicable. Okay, so please remember, this is very important, that only in case if acceleration is constant, then this equations of motion is applicable. Otherwise, this equation of motion is not applicable. Okay, so the question, then how do we solve that type of question in which acceleration is not, sorry, acceleration is variable? So that you will get to know in class 11. Okay, okay, there we take help of the calculus, okay, of integration and differentiation, okay, in case of a variable acceleration. For now, I think almost every question you will solve in that acceleration will remain constant. Okay, but remember this point, that this equation of motion is applicable only when acceleration is constant, not variable. Okay, now we will derive all this equation of motion by the graphical method. Okay, so suppose there is a bus moving along a straight line. Again, it is written with uniform acceleration. That means acceleration is constant. I am saying this thing again and again because this is very important. Sometimes students what they do, they just simply apply the equation of motion. Okay, they are not seeing that whether acceleration is constant or not. So please keep this in mind. You will get the answer, and that one option will be there in one of the four options. Okay, so you will mark and you will seem happy that I got the answer, but that's wrong, because the equation of motion is only applicable when acceleration is constant. Okay, now bus is starting along a straight line with uniform acceleration. So let's say initially the speed of the bus is u. Finally, at time t, the speed of the velocity is v, which is final velocity. Okay, now let's say from A to B, displacement of the body is s. Okay, so initially at t equals to 0, velocity is u, and after time t, velocity is v. Okay, and we already discussed about velocity time graph. Yes or no? We plot the values. Okay, so if we plot the values on velocity time graph, so initially at t equals to 0, velocity is u, and after time t, the velocity is v. Yes or no? So this graph we will get. Yes or no? From A to B. Okay. Now tell me, uh, what is the slope of this graph? What is the slope of this graph? What is the slope of velocity time graph? Tell me. Everyone know what is slope? Change in y coordinate upon change in x coordinate. Now change in y coordinate is change in velocity. Change in x coordinate is change in time. So change in velocity with respect to time is acceleration. Yes or no? Yes or no? Ane? Okay, I will explain, or you can see the recording also. Ane? Okay. Okay. So if we talk about the slope, so slope is nothing but change in y coordinate upon change in x coordinate. Okay. So we know that here initial velocity is u. Okay. Now we know that suppose coordinates of point D is 0 comma u, and the coordinates of point B is you can say t comma v. Yes or no? Any doubt till here? Any doubt in coordinates of D and B? coordinates of D here is 0 comma u, that is x comma y. Coordinate of B is t comma v, that is x comma y. Sorry, yes, x comma y, that is t comma v. Yes or no? Now, what is slope? Here, slope is nothing but acceleration, change in y coordinate. Now, change in y coordinate is coordinate, final coordinate minus initial coordinate. So, v minus u upon change in x coordinate. So, x coordinate finally is t, initially is 0. So, t minus 0. So, can we say that a is equals to v minus u by t? Now, cross multiply here, you will get a into t is equals to v minus u, or after rearranging this equation, we can write v is equals to u plus at. Yes or no? Because we know that slope of the velocity time graph is nothing but acceleration. Yes? Okay. Now you can see here, suppose from O to D, this distance from O to D is u. So we can say the distance from A to E is also u. Okay, because from O to D and E to A distance is same. Okay, now this whole distance from O to C is velocity, that is v. Okay, so can we say that final velocity is v, which is equals to OC? So this distance from B to A, this distance from B to A is nothing but total is v, and from A to E is u. So this A to B is v minus u. Yes or no? Any doubt? But any doubt till here? Yes or no? Anyone? Okay, very good. So time is OE. Now, what is OC? So from O to C, from O to C, from O to C, OC is nothing but OD plus CD. Yes or no? So this distance CD, this distance CD is equals to total distance, which is OC minus OD. Now total distance is V and OD is U. So this is V minus U. Okay, which is final velocity minus initial velocity, which is final velocity minus initial velocity. Okay, now CD is change in velocity, and we know that for velocity time relation, which is v is equals to u plus at, acceleration is change in velocity upon time. So acceleration is a, change in velocity cd upon time is t, and we know that cd is equals to v minus u. Okay, cd is equals to v minus u. So v minus u is equals to at, or we can write v is equals to u plus at, which is the first kinematical equation. So anyone, if having any doubt in first kinematical equation or in any line or in any step, you can ask me. Anyone having any doubt? Yes or no? Anyone, any doubt in first kinematical equation? No? Okay. Rudra, Anna, Kamalan, Arush, any doubt? Anna? Okay, okay, very good. Aditi. Okay. Now we'll talk about the second equation for displacement time relation. Okay, can anyone tell me how we'll derive the second equation of motion with the help of this graph? And we already discussed that point also while we were discussing the graphs. So can anyone tell me how we will derive the displacement time relation with the help of graphs? This given graph, velocity time. Please tell me. Any idea? Anyone? How will derive b is equals to, sorry, s is equals to ut plus half at square? Tell me. Yes, Rudra. V square. Arush, what is this? V. I think this is v square is equals to u square plus 2s. Better this is third equation of motion. I'm asking about s is equals to ut plus half at square. I'm asking s is equals to ut plus half at square. Okay, let's see. We know that second kinematical equation is S is equals to ut plus half a t square. Okay, what is the area under velocity time graph? Area under velocity time graph. Tell me, everyone, what is the area under velocity time graph? We solved the question in the starting of the class. What is the area under velocity time graph? What is the area under velocity time graph? Aditi, Samagna, what is the area under velocity time graph? Distance. Yes or no? Distance or displacement? Okay. Now we know that area under velocity time graph is displacement. Area under velocity time graph is displacement. And if the body is going from point D, now the graph is D to B. Okay, this is the graph. Yes or no? And we want to calculate the area under the graph. So this is the area we want to calculate. Yes or no? Now I'm dividing this area into two parts. First one is this triangle. First one is this triangle. Okay, and the second one is this rectangle. Okay, second one is this rectangle. Okay, now you can tell me the area. Now the shaded region in the area is of quadrilateral. Okay, quadrilateral DOEV is made up of this triangle, sorry, this rectangle and this triangle. Yes or no? Now if we add these two areas, we will get the displacement. Yes or no? Now area of rectangle is length into breadth. Now the length, this from D to A, and area of triangle is half base into height. Okay, now this length is OE. Yes or no? This length OE into AE, length into breadth. Yes or no? Now please tell me, what is OE? What is the value of OE in terms of time, velocity, whatever? Tell me, what is OE here? I want answer. Time. And what is AE? What is AE? Velocity, which is equals to what? U minus V minus U. AE is equals to U. Yes or no? So, okay. Now if we talk about the rectangle, so area of rectangle is half base into height. Now half into base is DA into height is AB. Okay, now we'll put the values. So DA is the triangle, okay, AB is the height of the triangle. AE is equals to U. Okay, OE is equals to DA is equals to time. Yes or no? Because what is traveling? Graph is from A to B and time taken by the body from A to B is T. So total time is T. Now CD is equals to AB. CD is equals to AB is equals to AT. Okay, is equals to AT. Now if we put all the values, so OE is equals to this half into AT. Yes or no? Any doubt? Any doubt? Till here, anyone having any doubt? You can see area is equals to area of the triangle, which is half base into height, plus area of the rectangle is base into height. Now put the values. Half dA is equals to T. Now AB is V minus U. AB is what? V minus U. This AB length is V minus U. And in first equation of motion, we know that V is equals to U plus AT. So V minus U is equals to AT. Okay. Plus OE into AE. Now OE is time, AE is U. Now in place of V minus U, we can write AT. So this is half t into at plus ut. Now this is equals to ut plus half t into at is half at square. And we know what is the area of velocity time graph, it's displacement. So this total ut plus half at square is equals to displacement. So s is equals to ut plus half at square, which is your second equation of motion. That is s is equals to ut plus half at square. Okay, any doubt? Is this clear to
No,
everyone?
sir. Yes, sir.
Very good. So this is your second kinematical equation. Very good. Now we'll see the third equation of motion, which is displacement velocity relation, which is v square is equals to u square minus plus 2as. Okay, again here the distance traveled is equals to area of the trapezium. Yes or no? D O E and B. This area of trapezium. Okay, so you can see here this area of trapezium is DOEB. Okay, now we can break again this trapezium in two parts. One is rectangle, another one is triangle. So, or you know the formula of area of trapezium, half sum of parallel sides into height. Okay, now this is equals to, we put the values of all the OD, BE and OE. Now if you put the value, you will get S is equals to half OD plus BE. Now here what is OD? This is U. This length is U. Now BE is total length. This total length is V. Yes or no? This is the final velocity of the body. Yes or no? Okay, now see here in third equation of motion, there is no time. Okay, there is no variable of time here. So we have to eliminate this time from this expression. Okay, so we know from first equation of motion that v is equals to u plus at. So v minus u is equals to at. So we can write here t is equals to v minus u by a. So from first equation of motion, we will put here in place of t, which is v minus u by a, because in third equation of motion there is no variable called time. Okay, so put a is equals to, we know that a is equals to v minus u by t, so t is equals to v minus u by a. We will put here in the second this first equation, so we'll get s is equals to half v plus u into v minus u by a. Now it is written half v plus u into v minus u by a. Now in one bracket we have a plus b, in another bracket we have a minus b. Now what is a plus b into a minus b? So that's equals to a square minus b square. Yes or no? A square minus b square is a minus b into a plus b. So here we can write in place of v plus u into v minus u is v square minus u square. Okay, so this is equals to v plus u into v minus u. 2a we multiplied here. Okay, so 2as, from here we get 2as is equals to v square minus u square. Okay, so from here we'll get third equation of motion, which is v square is equals to u square plus 2as. So any doubt in any equation of motion, anyone? You can ask me in any line, in any concept, in any step. Anyone? Any doubt in any equations of motion? Yes or no? Everyone, anyone, any doubt? Tell me yes or no. Rudra.
No doubt, sir.